In the last two videos, we have met vertical asymptotes and horizontal asymptotes for rational functions. This video is all about rational functions and holes in the graph. If I look at this rational function, I can tell right away that there's no horizontal asymptote because the degree of the numerator is larger than the degree of the denominator. I might naively for a moment think there's a vertical asymptote at 2 because that's where the bottom is equal to 0. But then I remember that rule for vertical asymptotes is only true if my rational function is in lowest terms. So if we factor the top, what we realize is that this rational function was not in lowest terms. In fact, it's actually equal to x plus 2. Anywhere both of these expressions were defined. Now that's important because the domain of this function does not include 2. That's where I'd be dividing by 0. So any x I plug into this is the same thing as when I plug it into this as long as x is in 2. Well, because f of x is actually this function and it's equal to this function but only on this domain. So that's important. 2 is not in the domain of this function. So, well, okay. So let's just see what happens here. If I was to graph this function, right, it's a line with a slope of 1 and a y-intercept of 2, it would look like that. But I have a problem. That's not the function I was supposed to graph. That's the line y equals x plus 2, not this function. And I can tell it's not that function because it includes a value at x equals 2. That would actually be up here at 4, so my line's not doing too great to scale. But we'll just pretend that that's the point at 2, 4. All right, so, well, for every other value near 2, I do get a point on that line, right? Because even if I plug in 1.9, right, this equation would work and I get 3.9. In fact, we could check that out, right? 1.9 squared minus 4 all over 1.9, parentheses on the bottom, 1.9 minus 2. 3.9, it works. Plug 1.9 in, all right, and even if I was to like plug in 1.99, right, something really close to 2, I'm going to get 3.99, right, because both the formulas give me the same value. The only thing I'm not allowed to plug in is 2. So what I do is I say, well, I just don't get that one value at x equals 2. There's a hole in the graph at 2, 4. That's what happens when we have factors that cancel. Factors that cancel give us holes. So, one of the first things we'll do when we have a rational function is we'll factor the top and bottom and look for factors that cancel because those will give us holes in the graph.